I saw this integral on YouTube, and I have a different methods to do it. Two methods. Actually, I did it in in my past videos. That was a little messy, and I would like to do it again here as a revised version, and I hope you will like it. Now, the first method, I start with substitution. I let x be e to the negative t. Therefore, log x is negative t. So my integral becomes sine negative t over negative t. Dx will be e to the negative t times negative 1, use the chain rule, and the dt. The boundary has been changed. When x equals to 0, this is infinity. When x equals to 1, it's 0. Okay, then this one is equal to negative cancel out. So it becomes sine t over t, and e to the negative t dt. This negative, I switch the order of boundary, become this. And I rewrite this, use x because these are just dummy variables. Sine x over x, e to the negative x, and dx. Yeah, it looks better. Now then I'm using the Feynman trick. I establish a function f of a as the integral from 0 to infinity sine x over x and e to the negative ax and the dx. Wow. And if I take the limit a approaches to infinity, f of a, well, this will be 0, right? So the whole thing will be 0. So this is useful for the future solution. Now then, I find the derivative of f with respect to a, or I write f prime of a, which is the taking partial derivatives with respect to a. This will be 0 to a. Well, x is constant, right? So this will be e to the negative ax times negative x, because x is constant. Okay, good. Then this would be negative taking out, x cancel out, sine x e to the negative ax dx. Yeah, this is my f prime of a. Okay, this is this. Then I continue by creating by parts. So this is a negative integral sine x. Now this, I write d e to the negative ax, then I multiply negative 1 over a, right? So that means this will be e to the negative ax dx. Yeah, this is this. Now I can use by parts, u dv. So this one is equal to 1 over a, negative gone, uv, u times v from 0 to infinity, minus v du, integral. V is this, du is cosine x dx. Good. When x is infinitive, that this will be 0. When x equals 0, this is 0. So this the whole thing is 0, right? Negative. Now here I want reorganized to create by parts again. So this would be cosine x times a d e to the negative ax, multiplied by negative 1 over a. So that will be the same thing as this one, dx. Yeah. Okay, this one is equal to by parts. Well, by parts, right? This one, taking out, is a square. So this one's taking out, multiply by this one is this. Now then, uv, u, v, minus v du, integral v. Du is a negative sign, right? Negative sign, x. So I change this one to plus. And then this one equal to 1 over this one. This one is infinity, therefore the whole thing 0. When x equals to 0, this is a 1. This is a 1. That becomes negative 1. And plus this. This is equal to negative f of a prime is equal to negative f prime of a. Right? This is negative that. See? So this one is equal to negative 1 over a squared minus f of a f prime of a. What is the left-hand side? Left-hand side is also this. Left-hand side is this. Right? See, we start from there. And therefore, what this one times that one. Sorry, a square here. This one times this one is this. This one times this one is that. Then I move over there. I get 1 plus 1 over a squared times f prime is equal to negative 1 over a squared. Therefore, my f prime of a is equal to negative 1 over a square, 1 plus a square. So this one is equal to negative 1, negative a square plus 1. Right? Good. Then my f prime, now my f of a is the antiderivative of this one. This one antiderivative is integrate is equal to negative arctangent a and plus c. Okay. Then we have this. As a approaches to infinity, f of a equal to 0. So this means 0 is equal to, this is infinity, therefore this is half pi plus c. Therefore c is half pi. Yeah, my integral I is when a equal to, when my integral is that when a equal to 1, right? Because I is this is I. This is my I. This is my f of a. So when a equal to 1 is my I. So my I is equal to f of a 1. So then I use this one, put it here, which means equal to negative arctangent 1 plus c. C is half pi. So this is equal to negative quarter pi plus half pi equal to quarter pi. So quarter pi is my solution to this integral. Okay. Yeah, my I is f of 1. My I is this. My f of a is this. When a equal to 1, it is my I. Okay, good. So I did it. This is method 1. Method 2, integral my sine log x. Well, we have a formula sine x is equal to e to the xi minus e to the negative xi, right? That is a basic formula for sine x. Therefore, this one is equal to, from 0 to 1, it's log x. This will be 2i e to the, well, let's not jump, e to the I log x minus e to the negative I log x and the dx. I'm sorry, a little smaller. So this one is equal to, is taking out 2i, right? Integral log x and dx. This is e to the log x to the power of n, x to the power of I. So that will be xi. This is this I could be written there. So it becomes negative x negative I. Well, I think it's okay. Yeah, it is. And let me use the space here, the 2I. And 1 over log x. Now, now, let me write one more step, not jumping. Okay. This is xi minus x to the negative I dx. This is 1 over 2I integral 1 over log x. So this is actually uh, x to the y from negative 1 to positive 1 and dx. Right? This is that. That means this is the, well, antiderivative of something. So we can find that antiderivative is equal to 1 over 2I. This antiderivative is x. This antiderivative with respect to y, this is yi, and the log x times the derivative of this one, which is I, then dy, then dx. Okay, this is actually the derivative of this one. That is the antiderivative of that, and this one is equal to that. This is the reason, you know, it makes this line, and this one equal to, well, it's you have a you have this in from -1 to 1. Huh? Yeah, that is the antiderivative. So then my whole integral becomes a double integral, while log x cancel out. So log cancel out, it becomes x to the yi and the dx and dy. This is the cancel out, right? I of I moved out. Okay, good. Now then we can switch the order of, for integrations. So let me do which one first? How about let me do the x first. So this one is equal to 1/2. And from -1 to 1. Then I do the integral for x first. So that will be x yi plus 1, right? yi plus 1 from 0 to 1. So that means I'm doing integral for the integral for x first. Then I do y later. So this one is equal to, this is 1/2 integral. When x equal to 1, it's a 1. When x equal to 0 is 0. So it's left as a dy over yi plus 1. Yeah, it's good. Then Then I rewrite this one, yi plus 1. This one I can write dyi times 1 over I. So this is a dy, right? It's the same thing as a dy. So it becomes 1 over 2I and the log yi plus 1. Yeah. dyi plus 1, the same thing. I can write as a dy plus 1. This is dy. This is dy, right? It's no difference. This becomes a log 1. So it becomes a 1 over 2I log 1 plus I, right? Minus log 1 minus I, right? This one minus this one is, I can combine them like this. And this one is equal to 1 over 2I log 1 minus I. This could be written as I times 1 minus I. This is I, this is 1. Yeah. So let's end up with 1 over 2I log I. Well, what's I? I is e to the I times half pi, right? That is I. This is I. I is, the argument is half pi. So this was this and times e to the half pi. Yeah, that is a quarter pi. Yeah, very good. Very nice. So this is the second method, and I hope you can follow, and I hope you like it. Thank you.